So this model was predicting the classification of the tickets, right? And then we decided to build a model that was also suggesting which actions to take in response to this ticket. And then there was also another model that was deciding which template answer to send back to the user, depending on what they were telling us. And so instead of creating all these different models, I thought that maybe that was a really nice application of multitask learning. And so I made it so that you can specify multiple outputs of multiple different data types. And in the end, we had basically one model that was capable of doing all these tasks using all these features. And that was basically the base of Ludwig. And then I started to add also images and all other things on top of that, and more people started to use it.
You're listening to Gradient Descent, a show about machine learning in the real world, and I'm your host, Lucas Biewald. Piero is a staff research scientist in the Hazy Research Group at Stanford University. He's a former founding member of Uber AI, where he created Ludwig, worked on applied projects, and published research on NLP. I'm super excited to talk to him today. All right, so Piero, I'd love to talk to you about your time at Uber and the things you worked on, but I think the thing you're maybe better known for and the main topic is probably your project Ludwig. So maybe for some of the people that might be listening or watching, could you just describe Ludwig at a high level?
Sure. So it's actually a tool that I built when I was working at Uber, mostly for myself. I wanted to try to minimize the amount of work that it would take me to onboard a new machine learning project. And what it resulted in is a tool that allows you to train and then deploy deep learning models without having to write code. And it does so by allowing you to specify a declarative configuration of your model. And depending on the data types that you specify for the inputs and the outputs to your model, it assembles a different deep learning model that solves that specific task and then trains it for you, and then you can deploy it.
So can we make this more concrete? So what if I want if my inputs were like bounding boxes, is that something that Ludwig would understand if it was images and bounding boxes? It would then sort of choose a model and learn, say, like predicting classes or something like that. Would that work?
So it doesn't, right now, there's no specific bounding boxes. It's something like a feature that they're going to add in the near future. But what you do in general is exactly that. So you specify your inputs and your outputs, and you specify what are their type. So for instance, if you want to do image classification, then you can say that your input is an image and your output is a class. Or if you want to do information extraction from text, then you can have text as input and, for instance, a sequence as output, where the sequence tells you what information you want to extract from the text. And any combination of these inputs and outputs allow you to create a different model, basically.
And it's the idea that underneath the hood, it picks the best state-of-the-art algorithm for any particular kind of input and output. Is that right?
So it works at three different levels, really. The basic level, you don't specify anything. You just specify your inputs and outputs and the types. And it uses some defaults that in most cases are again, pretty reasonable defaults. Things that are for those kind of types of inputs and outputs, state of the art in the literature. But you can also have full control over all the details of the models that are being used. So for instance, if you're providing text, then you can specify that you want to encode it using an RNN, or you want to encode it using a transformer or a CNN or a pre-trained model like BERT. You can choose among these options. And you can also change all the different parameters of these options. For instance, for the RNN, you can say how many layers of RNN, or if you want to use an LSTM cell or a GRU cell, or the size of the hidden state, all the parameters that you may want to change for those models, you can change them. And additionally, one thing that we recently introduced in version 0.3 is the capability to do hyperparameter optimization, so that you can say, I want to use an RNN, but I don't know how many layers do I want to use. And then you can say, I have this range between 1 and 10, and figure out which is the best parameter configuration for this problem.
And what does it do underneath the hood? Does it have some kind of smart system for finding the best set of hyperparameters?
Yeah, so first of all, the models that it trains are TensorFlow 2 models right now. We're also thinking about adding additional backends, but so the output in the end will be a TensorFlow 2 model that you can use for whatever purpose you want. And for the hyperparameter optimization, there's also, for the parameter optimization process itself, there's a declarative configuration you can give, and you can specify if you want to optimize it using different algorithms. At the moment, there's only 3 supported, which is grid search, random search, and a Bayesian optimization algorithm called PyShot. In the near future, we're going to add more. In particular, we want to integrate with Raytune that has many of those algorithms already ready to be used. And also, you can specify where do you want to execute the hyperparameter optimization. If you have a laptop, maybe you want to execute it just on your machine. Or if you have a machine with a GPU, you may want to exploit the GPU. Or if you have multiprocessing and multiple GPUs, you can run the training in parallel. And also, if you have access to a cluster, then you can run on the cluster a Kubernetes cluster with multiple machines with multiple GPUs.
Does Ledwig include data preparation or data augmentation techniques? Like, is that something you can do with it also? Because I know that's super important to many fields these days.
Yeah, so for data preprocessing, there are a bunch of things that Ludwig provides and a bunch of things that it doesn't provide. In particular, because that's not 100% the main focus, at least so far. It has not been 100% the focus of the library. So we provide some relatively basic functionalities. And if you have some specific need for preprocessing, we would suggest to do some preprocessing beforehand, before providing the data to Ludwig. But things that Ludwig does automatically are, for instance, a normalization of features, some tokenization of different sequences or text features. For images, we do resizing, cropping, all like pretty standard things, nothing crazy, but something that is useful for having a kind of an end-to-end kind of experience. In terms of augmentation, currently we don't have any augmentation that you can do right out of the box, but it's one of the things that we want to add in version 0.4 of the package.
I think one of the things that's striking about your library is, I think some libraries try to help people that do write code do machine learning without a deep knowledge of machine learning. But I think your library, if I recall correctly, says right in the top, we're trying to make it possible to do machine learning without actually writing any code at all. So that seems like a grander ambition. Can you talk a little bit about what made you come to that, and maybe what design decisions you make differently to try to enable that?
So I think, to a certain extent, it's a little bit aspirational too, right? Because there is still something that you have to provide, in this case, this declarative definition of your model. But I believe that it's so much simpler to write this configuration file than it is to write code. Then, to some intents and purposes, it actually opens up the possibility for more people to try out to use these models. So that was, to a certain extent, the intent. In terms of the design decisions, I think the main one that allows for this level of abstraction is probably the choice that I made to be, as you were saying before, opinionated about the structure of the models, and the fact that there are some data types that I support and some data types that I don't support. If your problem is within the realm of those data types that I support, then I make it really easy for you. If it's outside, then, well, either you can go and implement it yourself, or you can extend Ludwig to actually incorporate also additional data types that you care about. And those data types, the fact that you can compose a data type, so the compositionality aspect of it, is what makes it general to cover many different use cases. And that's probably the main, let's say, secret sauce. But this is not so secret because it's an open source project, but it's probably part where the magic is. Let's put it this way.
Can you describe how you would compose a data set? Can you give me a concrete example of that? A data type, sorry.
Yeah. So again, one example, we've been through some examples like text input, category output, it's a text classifier. But the interesting thing is that, so in some libraries, what you have is they provide you with some templates. Like, for instance, the Turi Core Create, I believe, that allows you to create models for Apple devices, does something similar, where you have, you have a task which is text classification, and then you have to provide the text input and the class output. And then there's another task that is, again, gives you some templates that you have to fit into. In Ludwig, it works the other way around. You start from the data and you look at the data that you have. And for instance, you have, if you want to classify an article, maybe you don't have only the text, you also have information about who's the author, and you also have information about the date when it was published. And maybe there is a subtitle and there's a separation between the title, the subtitle, and the body. And so what you could do with Ludwig easily, you can say, well, the title is a text input feature, but also the subtitle is a separate in-text input feature, and the body is a separate input feature. And the author is a category, because maybe I have, I'm working for a website and the website has 20 different authors. And information about the author will allow me to figure out, because maybe many authors maybe publish in a specific topic. And so that's additional signal that you will have when you're trying to figure out what class this new news article belongs to. And also time, because maybe a certain moment in time there was a spike of interest in a specific topic, and so knowing that an article was published in a specific date, that helps you figuring out what type of article this is. And so with Ludwig, it's super easy to specify all these different inputs from different data types. It's just a list. You just say the name of your feature and the type, and it's a list of those things, and that's all you have to do to have a model that combines all these different inputs into the same architecture, really.
What do you do if your data, the types of your data are inconsistent? Can Ludwig handle that?
What do you mean by inconsistent here?
I guess, like, what if my input data had, like, I mean, missing values might be the simplest case, right? But I'm thinking of like the cases that people come to me with, and they want to do some classification, some crazy data set. Like maybe there's like sometimes multiple authors, like maybe there's, I'm just thinking of all these edge cases. Like, how do you deal with that?
I see. So, well, let's say for cleaning the missing values things, Ludwig does some of it for you. You can specify, a default filling value, or you can specify to default to fill with, some statistics, like with the mean, with the max, these kind of things, which are pretty straightforward. Ludwig allows you to do all these things, so that's good. But if the inconsistencies are bigger, like for instance, in some cases there's multiple authors, well, you either treat it as a different data type altogether. For instance, set is a data type in Ludwig. So if you have multiple authors, you can treat it as a set rather than treating it as a class, for instance, as a category. And so because I have multiple of those data types, like for instance, date is a data type, the geolocation is a data type, and so on and so on, I think you will have a relatively easy time to find a data type that fits the type of data that you have. And again, if not, Ludwig is really easy to extend to add a data type that kind of matches your specific use case if you want to.
So do you have examples of people that used Ludwig that really couldn't write any code? Do you know people that have tried that?
Yeah, so there is this really interesting example that I've witnessed, I would say, there are a couple articles online from a person who's an expert in SEO, search engine optimization, and they wrote a couple articles on a SEO blog about using Ludwig for doing some predictions that are specifically useful for SEO purposes. And I believe, most of these people don't have a programming background, they cannot code. And so it was really nice to see people using it for that purpose. And another fun example that I have, so I don't know how much coding did this guy knew, but okay. So there was this application of Ludwig there's a published article by the Max Planck Institute on analysis of some biological images I think it was about worms or cells of worms. I don't remember exactly. But the point was that the person that was using it was a biologist, was not a computer scientist. And what he told me is that he would not have been able to implement, it was using ResNets within Ludwig. He would not have been able to implement a ResNet by himself. And so Ludwig enabled him to actually, to do this kind of research that otherwise would not have been easy for him to do. So these are like some examples of what you were talking about that I'm pretty proud of.
Yeah, that you should be proud of that. That's really impressive. I guess Ludwig came out of, though, your use cases, and obviously you're a very skilled coder. Like, what were you working on at the time at Uber that inspired you to make Ludwig?
Yeah, so the whole point is that I'm lazy and I don't want to do the same thing twice. Well, I mean, twice is fine. 3 times, I basically try to automate it for myself, for my own sake, right? And so I was working on this project called Cota. There's a couple articles online if you're interested about it. It's like a customer support model that basically at the beginning we were treating the problem as a text classification problem. So we had the input tickets, and we wanted to predict what type of ticket this was, because depending on the type, they were routed to different customer support representatives.
And maybe just before you get too far into it, could you like describe what's the scenario, what's an example ticket, and what would be an example class that
Yeah,
they
so I
might
mean, I
get?
was working at Uber, so one example was like, I don't know, my ride was canceled, I want my money back, or something like that.
Mm-hmm.
And the class, there were like about, I think, 2,000 classes, different classes that the ticket could belong to, which could be, appeasement request, or lost item, or food not delivered, because there's also a Uber Eats side of things, right? So there was like a really wide range of possible types of issues that could happen. And again, at the beginning, we were treating it as a tax classification problem. But then the PM working on this problem came to me and said, there is availability for additional features here. Like, for instance, we can extract some features from the user that is sending this message. For instance, if they were using the driver app or the rider app or the Uber Eats app when they were sending this message. And so that was, again, additional signal that we wanted to integrate into the model. And well, I did it once and that was fine. But then they came back to me with additional features that were related, for instance, to the ride that they were taking. And I said, okay, so these features some of them are numbers, some of them are binary values, some of them are categories. Let's make it something generic so that if they come to me again with more features to add, I will not have, it would be really easy for me to do that. And so that's, the part that I covered for the inputs. And then the same happened to the outputs, because we had, so this model was predicting the classification of the tickets, right? And then we decided to build a model that was also suggesting which actions to take in response to this ticket. And then there was also another model that was deciding which template answer to send back to the user, depending on what they were telling us. And so instead of creating all these different models, I thought that maybe that was a really nice application of multitask learning. And so I made it so that you can specify multiple outputs of multiple different data types. And in the end, we had basically one model that was capable of doing all these tasks using all these features. And that was basically the base of Ludwig. And then I started to add also images and all other things on top of that. And more people started to use it within the organization. And then later on, we decided finally to release it as open source, because we thought that also other people outside Uber could find some value in using it.
That's so cool. Do you anticipate more people kind of moving to this model of not worrying about the underlying architecture of what's happening, and I guess what should people then focus on if they're using Ludwig? If you want to make your model better, what is there left to do?
So I think there's two aspects there. So I would say, I believe, I may be wrong, but I believe that there's much more people in the world that doesn't know how to implement a deep learning model than people that knows how to implement a deep learning model, right? And so I would say, I believe that there's also value that Ludwig can give to an expert, in particular because it makes it easy to compare different models, makes it very easy for you to have a baseline, for instance. That it's definitely something that is useful in many situations, right? But if you are a super expert and you want to implement, if you're a researcher and you're creating a new model, then probably you want to implement it from scratch and have full control over it. But I think there's the rest of us, the rest of the people that don't know how to implement a deep learning model and doesn't have the time and the resources to study it. For those people, I think there's a lot of value to be unlocked by using a tool like Ludwig. And in terms of then what do you do if you're not writing your model? Well, there's all sorts of other things, right? There's, first of all, you can figure out the upper parameters, both by hand and also automatically. And also, there's also like other things, like you can try to, for instance, figure out which subsets of data, the model performs better or worse, and so have some sort of outer loop kind of explainability and trying to make sure that your model is safe and that it's non-discriminating, all these sort of things. And usually the way you actually approach these kind of problems is to add more data in a specific way that tries to introduce and solve these problems in the behavior of the model, right? So I would say, in general, this is like a piece of a human-centered kind of process. And so the human has a lot of things to do in this process by labeling data, adjusting the model, integrating the model into a broader application. So there's a lot still to do with for the human, I believe.
Is it part of Ludwig's scope to guide the human building the model into things that are likely to help the model perform better? Like, I'll give you an example. I often help people who don't have a lot of experience train models. And, some of the mistakes they make are kind of surprising to people that are like in the field, but make total sense if you step back. Like, I've noticed in some cases, people will have so many classes that they don't have an example, literally even one example of every class. And then they're surprised when the model can't predict that class where they've literally not provided an example of that. And I can think of lots of different ways that people can shoot themselves in the foot when they don't have experience with this type of thing. Is it part of Ludwig's scope to help people avoid those bad situations?
So that's a really interesting question. I would say the scope is changing over time, to be honest, right? At the beginning, the scope, as I described, like the beginning, the scope was to build a text classifier, and then it became like a much more generic thing over time. So also with this, with regards to what you're asking, it's something that we don't so let's put it this way: Ludwig nudges you in a direction, but it does so in particular for model architecture choices and model training and building. It has some defaults that are kind of reasonable and helps you figure out easily with the parameters what to do. What it does not do right now is what you described, like the more higher level kind of problems. Like if if is the problem you're trying to solve a problem that is solvable with a machine learning algorithm to begin with, for instance, that's something that is right now out of the scope of Ludwig. You basically start with something that you believe could be useful, signal that kind of makes sense, and distribution of classes, for instance, that kind of makes sense.
This is slightly switching gears, but this has been a surprisingly interesting question recently. What do you think about Python as sort of the lingua franca of?
But what you're saying is very interesting because there could be some even relatively easy checks that one could do beforehand and return to the user saying, oh, there are class A, B, and C that don't have examples. Maybe you want to provide them if you want to have good performance or something like that. That could be easily added. So that's something that I would take into consideration.
Machine learning? Like, do you think that Python is going to stay the dominant language for people building models, or maybe there'll be something even more high level if your vision is that people don't even need to write code to build these models?
Yeah, I mean, so okay, there's several aspects to this question. I think also it depends on who is the user. I believe that, for instance, if you think about databases before SQL was invented, well, people had to code their own databases by hand. Well, not really SQL, but I mean the relational database in general, introduction of those kind of management systems. People had to implement their databases by hand, and they were using files and hierarchies as a way. The file system was basically an early example of a database, really. And then there was this change into the paradigm of the way that people interacted with data by using a language like SQL that is more declarative, doesn't require you to express how things should be computed, but actually what you want to compute. And I think that a similar shift could happen also for machine learning. Although this is true for a set of users, which are, the final users, those ones that use the models, much less so for the people that actually produce the models. For the people that produce the model, I think I actually love Python. I think it's a great language, has really nice syntax. It's very simple to pick up, very simple to look at someone else's code and improve it and change it. So I think it's a great language. But I can also imagine that we could be moving towards languages that are probably a little bit more efficient. And I mean, the efficiency of using Python right now is basically wrapping C stuff. Maybe there is a world where we start to write models in Rust, even if Rust is a little bit too complicated, probably. But I believe that or maybe in Julia, I don't know, there could be like some candidates language to dethrone Python as the lingua franca for machine learning. Although I don't see that happening in the very near future, to be honest.
Hmm. How do you decide what default model you give someone for a certain configuration, especially when the research is changing so fast. And I would say, especially maybe in natural language processing right now, which just sounds like where Ludwig started. Like, does it ever get contentious to decide what default to put in? Because I would think that a lot of no code users, if they have no experience in machine learning, they're probably going to stick to the default, or at least even if they do a hyperparameter search, you have to constrain it somehow to some set of defaults. How do you think about that?
This is a great point, and also, there are many aspects, in my opinion, that in they're not. I mean, there are some researchers that are actually talking about these aspects, but they're not, let's say, mainstream in particular in research. And those aspects are like, performance is one dimension that a potential user of a system like this may care about, but there are also other dimensions. There could be, speed of inference, or cost of training, or length of training, or carbon footprint of your models, and so on, right? So it's really difficult to figure out a default that accommodates all these aspects, right? It's basically right now is impossible. What I usually tend to do is to provide defaults that are on the, let's say, less computational expensive side. So for instance, I will not have as a default to use, T5 as a model for encoding language, just because the amount of users that could actually fine tune a T5 model will be, relatively small, and also the degree of advantage that they would get over like a smaller model that maybe not as big as to justify the increased cost in computational cost, right? So I try to, balance towards the inexpensive, but leaving the option for the more expensive. So that's one thing I do. And on the other hand, this is something that I'm really interested in doing. I'm starting to do some little, research around it. One thing that I want to do is I want to do like a really large scale comparative study. This is actually a little bit more on what I do at Stanford more than what I do for specifically for Ludwig. But I'm really curious in doing a large comparative study among different models with different hyperparameter optimization values on different tasks. And maybe one interesting outcome of that could be something that looks like a recommender system that tells you, I have this new data set with this amount of data of these data types. What model do you suggest me to use given these constraints? Because I think that the constraints are important. You may say like, I want only to see models that would take less than 0.1, less than 10 milliseconds to run inference on. And so maybe they will rule out some of the more expensive, but also more effective models, right? So depending on the constraints, like suggesting something that depends on the constraints, I think would be really useful.
Well, now that we have a weights and biases integration, we could give you the data of all the users that chose to make their projects open, and that might actually give you kind of real world evaluation of the different things that work and don't work. It would be super cool to see if that was useful.
Absolutely. I mean, this is something that with your data you probably can already do, right? We could think about ways to collaborate on that. Definitely, this sounds very fun.
That'd be fun. Stepping back a little bit, one thing that I wanted to ask you is I noticed that you've been doing NLP work for quite a long time. I think, before Uber, you were at a startup bought by Uber. And before that, I think you had your own startup doing natural language processing. So you've been doing it for, over a
Yes.
decade. I'm kind of curious the perspective of someone like you on kind of the new stuff that we're seeing. Like, do you feel like, GPT-3 is like a real step function change in the quality of NLP and kind of changes the possible applications, or was it sort of inevitable? I mean, how do you look at the field and how do you feel the field has changed in the time that you've been working in it?
Yeah, so I mean, that's true. I've been working for at least 10 years right now, basically in the field. So I've seen quite a few waves. Tasks that were interesting 10 years ago are still interesting today. So there are many things that were unsolved back then and still unsolved right now. We did progress in terms of performance, but I would say the general framework for how the problems and how we approach them hasn't changed a lot. When we were using neural networks before, we were using SVMs, but overall, there was not a huge change, in particular in the way things work in industry, really. But in particular, the capabilities for few shot, actually, the capabilities for interacting with the model itself through language that is, shown by something like GPT-3, those are kind of change kind of the paradigm of interaction with those systems. And I think I'm not sure of the commercial usefulness and application of something like that. But what I'm sure of is giving having like a general system to which you could give a really small amount of examples, and then the system picks on that and is able to perform the same kind of task that you've shown it on unseen data right off the bat without needing training for specific training for solving those tasks. That's a very compelling thing and something that may bring the industry in a different direction, I believe. So I see an interesting world in the future where that shift happens. Although I still have my questions. Like the jury is still, it's not. We haven't settled on a final answer on how much and in which scenarios this actually works to the point that we can actually use it. But let's see about that. I'm curious to see what the near future holds.
Cool. Well, I can see we're running out of time, and we always end on 2 questions, and I want to give you a little bit of time to answer these questions. The penultimate question that we ask is, what is a topic in machine learning broadly that you think doesn't get as much attention as it deserves?
So I think now it's getting a little bit more attention than it was before. So I may be a little bit out of time giving this answer, but I believe that something that I think it's very important is systematic generalization. And again, there's been work from Marco Baroni, Brendan Lake, and also Josh Tannenbaum on this topic, but has not been for a long time at the forefront of research. But it's something that is super interesting, and it's something that, if solved, may unlock many applications also of machine learning, where now we have a hard time applying machine learning. For instance, in scenarios where there's a lot of shift in distribution of data over time, or in scenarios where we need to train from less data. If we had a solution for systematic generalization, we could be able to apply machine learning models also in these scenarios. So I'm really looking forward to more research on that topic.
And could you define what systematic generalization means?
Yeah, I may be butchering it a little bit, but at least the way I see it is the fact that you have a model that can figure out a way to generalize beyond the training data, obviously, but generalize in a way that is systematic. So that learns that I can give you like a practical example of all the specific instances of a specific phenomenon, it behaves in the same way. Like it realizes that, for instance, if you're talking about text, right, that the is invariant to the choice of entities, or is invariant to the choice of some synonyms when it's returning its predictions. And I think it's really important because those models that exhibit a behavior like that are models that we can trust.
Cool. Well, the final question is, and maybe this is, you could really rely on your experience at Uber here. What's the hardest part about taking an ML project from conceiving of the idea to getting it deployed in production and, doing something useful?
Yeah, I think the answer to this changes a lot depending on the type of kind of organization that you're working in. Like if you're in a startup, you can do things differently. If you're in a big organization, it may be different. So I can speak in particular for the big organization kind of setting. I can say that in particular for researchers, one thing that is difficult is then to put whatever you obtained in your research into production. And there's at least two sets of problems why that is difficult. One is like a practical one, an engineering one. Usually the infrastructure for deployment is not the same that you used for training your models. And so there's a mismatch there that has to be filled. And also maybe your models are a little bit too slow for what are the needs for inference at scale. And so there needs to be some compromises there. And that's one of the problems. But the other problem, which in my opinion, it's more important because it's not a technical one, it's harder to solve, is a misalignment in the goals, really, of what the model should be doing. you may be optimizing your model for, with whatever metric that you care about, let's say cross entropy loss, or maybe you have a ranking problem and you're optimizing for the mean reciprocal rank or whatever other metric you're using for both optimization and evaluation. But in the end, in many real scenarios, those metrics are just proxies for what you actually care about. And what you actually care about, if you're doing, for instance, a recommender system, is you care about how many people are clicking on the items that you are suggesting. And maybe if there's like a store, how many people are actually buying something. You may have the model that is 20%, has 20% better MRR offline. You deploy it and people don't buy more. That's not a model that is going to be deployed, right? And so that's something that machine learning people usually don't think a lot about. And it's something that, in my experience, has been the main attrition point between developing something offline and then getting something that deployed in for real in front of the users.
That makes sense. Well, thank you so much, Piero. It's a real pleasure to talk to you.
Yeah, thank you for the really interesting questions. It was really fun to chat with you too.
Yeah, thank you. Thanks for listening to another episode of Gradient Descent. Doing these interviews are a lot of fun, and it's especially fun for me when I can actually hear from the people that are listening to the episodes. So if you wouldn't mind leaving a comment and telling me what you think or starting a conversation, that would make me inspired to do more of these episodes. And also, if you wouldn't mind liking and subscribing, I'd appreciate that a lot.